Oh no. Okay, lady. I think you said it was section 9.2. Oh, are you talking about, no, wait a minute. Let me see what you're talking about. Number 9. Whoa. All right. So the first step on this, well, actually, the very first step is to realize this is a tangent question, which is one of those identities we didn't have to memorize. So you can just have that green sheet open. Is that cool? No matter what problem you're looking at like this, these problems that are trig functions of angles we don't have memorized, the whole point is to first figure out how to break that angle up into two angles that I do have memorized. Is that cool? Let me see. Here comes chat. I'm not sure when you keep saying what tan to use. I don't know what that means. So what was your first step on this? Break it up. That's true. Now be a little more specific. So I want to break up 19 pi over 12. One thing to realize real quick. Okay, so you did 10 pi over 12 plus 9 pi over 12. That looks good because that would be 5 pi over 6, which is related to a reference angle I know. And this would be 3 pi over 4, which again, so that's good choice. So I have a feeling that your question is really, which identity do we use, right? I'll bet you anything. Maybe. Maybe, all right. And of course, let me see. Is there a way I can do this? Dadgummit. Not really. Well, shoot. Now I really can't do shit. Damn it. All right. So we got that figured out. So let me take a step back. I'm gonna have to clear this and stop doing this. I can't handle so much freaking technology. Let me see. So you got this bad boy here. Just to remind you guys, you've got the, where'd you go? Where'd you go? Here you are. Bam. So you can always have this sitting next to you. I would have this sitting next to you, and the ones you have to memorize, I would try not to look. I would put down something, and then I would look to double check. And the more problems you do, the more it would hopefully get in your head. So obviously we want to use this guy here. Yeah, all right. And the answer is, there's no way in the world you can know ahead of time what the answer should be, except for, does somebody know what quadrant this is in?
Would it be in the third quadrant?
Yeah, why do you say that?
Because it's more than 1 pi and less than 2 pi, so you know it's on the bottom half.
Sure.
And then there's a remainder with it. Yeah, that just
Look here, right here. Right here is where you see something interesting. So it's actually a little bit more than 3 pi over 2, right? So it's actually in the fourth quadrant, just barely. I like it. Is everybody with me? So you do have the option. So what you did is fine. You made it, let me see, remember, 10 pi over 12 plus 19 pi over 12. No, Jeff, 9 pi over 12. Barf. The original question, stay with me now. The original question, what's this reference angle? I can do reference angles. I don't care what the angle is, right? So 2 pi would be 24 pi over 12. So this would be 5 pi over 12, which I believe is an angle that we actually looked at the other day to try to break it up. Do you have to do that? No, you don't. But I would, just to make the number smaller, easier to work with. But it doesn't matter. You can still do this. And now I can see I'm going to use the plus option. So I'm going to use the plus and the minus, right? And the only thing you know, should it be negative or positive, considering what quadrant we're in? And what is it you're considering to know that? Well, tangent, sine over cosine. Does sine and cosine have the same SIGN or different SIGNs in quadrant 4? Different. So tangent's going to be negative here. So that's the thing I'm looking for. The answer better be negative. Other than that, I don't know. It's probably going to be a little large because what's tangent of 3 pi over 2? I'm sorry, not a little large, a little small. What's tangent of 3 pi over 2? A little large. I was right the first time. Anybody? What's sine of 3 pi over 2?
It's 1, right? -1.
Yeah, sine is -1. And what's cosine of 3 pi over 2?
0.
0. So what's tangent? It approaches tangent sine over cosine. So it approaches
-infinity.
Yeah, negative infinity. I like it. So it's going to be big negative. So as long as your answer is kind of a big negative, then you're on the right track. As far as what the actual number is, who the shit knows, right? Tangent's got the infinite range. Tangent goes from negative infinity to infinity. So any answer could happen. Sine and cosine are nice and bounded. They can only be between 1 and -1, right? So if I get a sine answer bigger than 1, I know I screwed up. But tangent, you don't know anything that specific. Is that all right? Is that okay? Person out there? Can we leave the radical in the denominator if there is one? Probably an exact answer, right? I'm always going to want, not always, Jeff. I'm very often going to want an exact answer. Yeah. What can you do to check it? You can do the work here and get your radical answers and plug it in the calculator, get a decimal, and then plug this in the calculator, get a decimal, and make sure they're the same, right? You can always check your work. You can just throw the dang thing in the calculator. Let me see what's happening out there. Something's coming in. Well, it depends on if there's something simple you could do. So yesterday we got an answer like something like this, and I didn't do shit with it. Well, obviously it wasn't this because I would have done something with that, hopefully. But I mean, if you get something like square root of 6 minus square root of 3 over 2, there's really nothing to do here. Yeah. Okay. How's everybody else? Any other questions, guys? Anything? Did anyone notice that I put up, I told you guys I was going to look for it. I couldn't find it, so I created a new one. I don't know how much I like this. Where'd it go? Here. Verifying trig identities. So this is a new handout. And at the top, I kind of try to give you things to look for, right? So pretty much we've talked about every single one of these. And I went over those 8 a little bit in the first video. So I've got, dadgummit, where are you at? I got one solution video, the second solution video. I'm not quite done yet. I started making the videos today. There's quite a few practice problems on this thing. So I'll finish that up tomorrow, hopefully. And I'm trying to do them going into it a little blind, right? I'm going, if you watch the videos, I'm like, oh, gee, I hope this works. You know, because I always hate it when, so what really sucks is when a teacher comes in and they have everything pre-done. So you don't see any of the thought process that goes in. But also what sucks is when a teacher hasn't done shit and they get stuck and they stand there for half an hour. And I've had that happen to me. Thankfully, not as a teacher, but as a student. And that's annoying as hell, right? So I'm trying to find a balance because you do need to see the struggle no matter how much math you know. I'm not going to look at something and go, That's this kind of problem. That's this kind of problem. I'm going to go, oh, shit, let's try this. Oh, shit, that's not working. All right, all right, all right. So we'll see. If you guys want to watch that, you can. And I keep forgetting that a while back I put this up here. So I don't know how you guys, I could just make a video for this, or we could look at it right now. This trig identity practice. I kind of forgot I had put this up here a while back. Any preference on that? Do you guys want me to make a video of this, or you guys want to look at a couple of these, or what?
Can we do a couple right now?
Sure. Let me see. I guess I could try to do it right here. Yeah, let's see how this works. Well, shit, no. Let me stop sharing. So if you want to go on a Canvas, it's up there in Unit 9. Let me open this up a better way for myself. Where are you, you crazy thing? Why are you giving me trouble? Is that you? That's you. Maybe that's you. That's you. All right, sweet. Come over here. Okay, so. Did we, am I correct? Did we, this looks familiar to me now. Did we not do these?
No, we did a few of them.
We did? Okay. Because I remember this guy. Yes, we did, didn't we? I remember that now. Okay, so I'm not insane, but I don't think we made it all the way down to here. There's some interesting stuff happening down here.
Yeah, we didn't make it that far down.
All right, give me just a second. I think I know. I think I saw. Hold on. Ah, there you go, Jeff. That's what. Oh, okay. I could post this if somebody reminds me. This is what we did. This beautiful thing. I have no idea what happened to this poor problem. But we didn't do these down here, which are kind of related to some more recent stuff, right? So let's look at these. Let's go ahead and finish this guy off, and then I'll see if you guys have any specific questions, and then we'll do some stuff on a 9.5. So this one is related to that. Well, what is this one related to? There's actually two different ways you could do this problem, which is kind of interesting. Does anyone have a suggestion? Oh, there's a chat coming in. Let me see. Oh, thank you. So this weekend, so I got a private chat about the next quiz. This weekend, I am going to finally put out the final homework timeline sheet. The quiz for Chapter 9 is obviously not going to happen on Monday. And if you look at the due dates, I think I'm going to push it back to next Thursday. Is anybody upset about that? All right, because I was going to say if anybody was, I would make it Tuesday. All right, so Chapter 9 quiz will be on next Thursday. Over the weekend, I'm going to update the homework timeline sheet and have it go all the way through to the end of the semester. And hopefully the dates won't have to change anymore. We'll find out. So there you go. Is that cool? I mean, that's, so the quiz will not be on Monday as it's listed right now. Also, do you guys remember this weekend we get an extra hour? Well, we get the hour back that they took away from us earlier in the spring, right? They stole it and now we're getting it back. No freaking interest. What the shit? It's just like the government. All right. Some year they should do it by half an hour and just stop. Just half an hour. Split the difference and then just stop. Why not? Okay. Is that cool? Any other questions before we get into this? All right. Any suggestions on what to use to do 2A? There's actually two valid ways to do 2A. And nobody's giving me anything. Nobody? Here's somebody. Okay, I got somebody saying half angle formula. I love it. I love it. Okay. If you don't remember the half angle formula, we're not taking a test or a quiz, so you can look it up. So does somebody have the, let me do this in a different color here. Scheisse. Oh, Jeff, let's not do it that way, buddy. I mix up my technologies and it just gets really sucky. What do you mean, Doug? It's not pi over 6. How do you mean? Yeah, 15 is not, 15 degrees is not pi over 6. You got to be careful. Let me see. I think that's what you're saying. I'm not sure. Oh, that's okay. That's okay. That's fine. This is why I could never be like a YouTuber or a Twitch streamer or something. I can't handle two things at once. Are you kidding me? All right. So what is cosine of theta over 2? Does anyone remember? I'll start us off. Plus or minus the square root.
1 plus cosine theta over 2.
Yes. Cool. All right. And then we got it. So what is theta going to be in this problem then?
30.
30. Kick ass. All right. Is anybody not with me? Again, if you don't have those that list of identities sitting next to you as you do homework, you're kind of insane. Right? Don't look at it all the time. I'm hoping you try to start getting in your head, and then maybe you check over and you're like, oh, I got it right. And it kind of gets in your head. I'm hoping. Or however you memorize things. I have no idea. So now I can rewrite this. Now, which one of these is going to be obviously? This is not a part of every answer. This is a choice we have to make based on where theta is. Based on where this is actually, theta over 2. And obviously cosine is which one of those for 15 degrees?
Positive.
Positive. Okay, so I'm going to make positive square root of 1 plus cosine of theta, which is 30, divided by 2. What's cosine of 30?
Pi over 3.
You're thinking about 30 degrees turned into radians, which would actually be pi over 6. I think that's what you're thinking. What's cosine of pi over 6? Cosine of 30.
Rad 3 over 2.
Yeah. When somebody chatted that same thing to me, thank you. Rad 3 over 2. And then one little thing I could do with this is I could double the top and the bottom. Do you guys see that? To get rid of that internal fraction. Right, so I'll get 2 plus rad 3 over 2. Chumbawamba. Now, if I really wanted to push this is something I wanted to do before, I think, and it just never had enough time to get into it. But does somebody see a different way you could do this problem? I do. Right? Right? So whatever answer I get from this better equal this shit, right? And what is kind of weird about this thing that we don't see all the time? What's a little weird about that expression that we got?
A radical and a radical.
Internal radical, yeah, which sounds like a horrible medical condition, right? Is it internal bleeding? No, it's worse. It's internal radical. Oh, shit. Or does that mean like your internal punk? I don't know, internal radical. All right, anyway, internal anarchist. So now if you do it this way, you just got to remember the cosine. Cosine's an asshole, me. There's a minus, so then I'm going to make this a plus, and then sine gets a turn. Real quick, let's just see what I'm just going to do this real quick. This is all shit you should know. Square root of 2 over 2, square root of 3 over 2, plus square root of 2 over 2, 1/2. Is that cool? Become a 3. So we got square root of 6 plus square root of 2 over 4. Now look at this and look at this. They are the same. They are the same. They are. Maybe I'll make that a bonus question. Say, prove that these two are the same. You can put it in the calculator and make sure, but they are. They are the same. It's kind of cool. Anyway, is everybody with me so far? So if I don't say to use half angle or difference formula, you could use either one, whichever one comes to your mind first. Okay, maybe. What can I use in part B? What kind of sucks is if that was a plus, the answer would be easy, right? Well, that's too bad. There's somebody else that I haven't heard from. Let me see. I got a chat. Maybe this is. Okay. Well, that's what we're talking about, though. All right. So how did I know? Yeah, exactly. Because 15 degrees is half of an angle that I know. That's it. Does that make sense? That's it. That's why I decided to use the half angle formula. Yeah. So let me think. I mean, that's a good question. Don't get me wrong. But that's, there's nothing in the problem that's going to tell you necessarily. I mean, I like to ask a question just like this. So I leave it open. You can do it either which way you want to, and I'll accept both answers. But it's just the fact this is not an angle I know, so I'm going to need identities help. Is this pi over 8? Do we know angles like pi over 8? Do you have those memorized? If you do, wow, shit. That's some cool shit, sort of. So I'm going to need identities help again. What's cosine squared minus sine squared? Anybody remember what that is?
Cosine 2 theta.
Yeah, cosine 2 theta. It's one of the 3 options for cosine 2 theta. And why is that cool? Because what is cosine of twice pi over 4? I'm sorry. Listen.
Thanks. Pi over 4.
Can't even, yeah, I'm sorry. Cosine of twice pi over 8. Is everybody with me? Why did I mix my variables here? Too bad. So whatever this angle was, and it was pi over 8, I can rewrite it as cosine of twice that. So cosine of pi over 4. And what's cosine of pi over 4?
Rad 2 over 2.
Rad 2 over 2. Bam. So I can do this by hand with an identities help, right? There ain't no way I could do pi over 8 shit by hand, but the expression went right into an identity for me. So I was able to do that. Okay, maybe. All right, I'm going to erase this. Oh, go ahead.
Sorry, I just want to make sure. So cosine squared of x minus sine squared of x equals cosine of 2x.
Yes.
Then, okay, sorry. And then we substitute the pi over 8 for the x.
Good.
And then it would just be pi over 4. Oh, and then that's 2 over 2. Okay, got it. Talking out loud. Thank you.
No worries. And that was sort of a clue too, that pi over 8 is an angle you don't know, but it's exactly half of an angle you do know. So it kind of leads you in the direction of what identity this probably relates to. All right. Where am I at? So last one here. This obviously, now real quick, I can rewrite this for myself as sine of twice some angle, right? Because that's what inverse trig functions are angles. Do you have to square root that or do you leave it? How do you mean? So let me bring this down here. Do you mean like make this into a decimal? Oh, okay. This is a really good question. All right. Let me focus on this for a second. The original problem, let's do blood red. All right. The original problem said cosine squared of weirdness minus sine squared of weirdness, right? That's the original problem. What is that equivalent to? That is equivalent to cosine of pi over 4. Is anybody not okay with what I just wrote? Because I wrote it already. I'm just writing it again and emphasizing what's happening. So pretty cool with the fact, whatever the shit this is, it's equal to this. How do I know that? Because we proved the identity that works no matter what the angle is. So will it work for this angle? Yeah, because it works no matter what the angle is. Is anybody not okay with that? So then, okay, let's see what's happening in chat. Okay, you're fine, dude. Don't not ask questions. You're fine. So I'm really appreciative that you asked that question, because this is a big part about math. If I take where I started and I write an equivalent thing, I don't have to worry about this shit anymore. So somebody was worried about, well, do we have to square root because it was squared? yeah, the original problem had squares and sine and shit in it, but I figured out that it's equivalent to this. So if I figure this answer out, I figured this answer out. And you can check it in the calculator if you want to, right? Okay, okay, I like it. So coming back, I keep wanting to do this the wrong way. Coming back to this guy. So pretty cool with that. I'm just rewriting a sine of twice an angle. And of course, what's sine of twice an angle? What's the identity for this?
Two sine theta cosine theta.
Okay. I'm really concerned. Is everybody really there? I know 3 of you are there. 4 of you are there. There's Doug. Somebody's there. Okay. I think you're all just like, well, if we just don't say anything, he's going to say it anyway in a minute. Damn it. I got to stop doing that shit. We'll sit here and stare at each other for half an hour. All right. I don't want to do that. So why did I do it this way? Because with this in the way, it's a little bit freakier, right? So let me just say, whatever this angle is, it looks like sine of twice that angle. And I know the identity for that. So now I can bring that angle in. I can say that's 2 sine of inverse tangent of 3/7 times cosine of inverse tangent of 3/7. I guess I should be, right? Now, how the hell do I do either one of these? What is inverse trig function set up by itself now?
You have sides to a triangle in each one.
Triangle, I like it. And so what would this side here be?
I can't see it.
Oh, am I in the way or something? This side.
I don't know if it's low enough on my screen.
Oh, shit. I can't. Oh, man. All right, wait a minute. What can I do about that? Doobie, doobie, doobie. All right, I'm going to get rid of this old stuff. All right, let me see. So here's the triangle. Here's the angle, right? And since it's tangent we're talking about, this must have been a 3 and this must have been a 7, right? And then once I get this done, I can do both of these. I don't have to draw one triangle because it's both using the same angle. So this will be 9 plus 49 square root of 58. So this will be twice. The sine will be 3 over add 58. So why don't I rationalize this? Because I know what's going to come next. 7 over add 58. And they rationalize themselves. That kicks so much ass. Let me stop for a minute. So what this problem is, it's putting together, using an identity together with dealing with inverse trig. That's what this problem is doing. So we have to be able to do this kind of problem by itself. And this problem has 2 of those things in it. All right. And they both use the same triangle. That kicks ass. So here I'll have 2 times 3 times 7 is 42. Answer life, the users, and everything. Square root of 58 times square root of 58 is 58. And then let me see what goes into both of those. Looks like at least 2. Yeah, I think only 2. 21 over 29. Beep, 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 beep. I mean, if I would have thrown now, some of you guys might say, I feel that way right now, but if I would have thrown this at you a week and a half ago, you're like, what the hell is that gibberish? but I'm hoping that you notice that stupid 2 is in the way. If that 2 wasn't there, then the sine could attack this directly. That's why I need an identity. I need an identity for a double angle. Okay, maybe. Can you do another problem like this? Sure. All right, let me see. I think I have, what did I just do? Oh, okay. You'll be fine, Jeff. Why can't I access anything? There we go. Do. Where is it? Okay, this was, I think, my blank sheet. Yeah, I just have a generic blank sheet. By the way, you know that, I don't know, what can you guys see right now? Probably still Canvas, right? Or whatever it was.
It's a blank sheet.
Oh, you see a blank sheet, sure. And do you see up here, Animaniacs is coming back out? All right. So let's do another example of this kind of problem that we just did. Let's see, let's do one like this. Cosine of twice, what, Jeff? Inverse cosecant of 4/3. I like it. So here with cosine of a double angle, you have a choice, right? So cosine of 2 theta is either cosine squared theta minus sine squared theta. Arg. Or it is, all right, so this is where I always have to say, I have to start here. This is where I start. And then I remember what everything is. So that's 1 minus 2 sine squared theta, or it's 2 cosine squared theta minus 1. So I have a choice. So it doesn't matter to me. So I would probably choose one of these two because then I have less trig functions in each, right? So I'm going to choose this one just because. So I can rewrite this as twice cosine squared of inverse cosecant of 4/3 minus 1. Is it pretty cool? Because what's my angle that I'm talking about? This is the angle I'm talking about right there. Let me stop for a minute. I always say for a minute. I never stop for a whole minute. You know what I mean? We haven't done one yet with that there, right? So one thing I do when I have to actually work with this is I write this a little more what it means. I put the square out there. So that's really what this means. It's when I put a little 2 on my trig function, it really means cosine of this thing all squared. Do you guys remember that? So when I write, like if I write sine squared theta, that really means sine of theta squared. That's what that means. We've just chosen that takes too long to write, which is really pathetic, but oh well. We're used to it. It's okay. So now I can focus all my attention on this problem right here. That's all I care about right now. So you guys take a minute and do that. I'll sit here and wait with bated breath. Now I feel like looking that phrase up. What does bated breath mean? Ooh. Ooh. All right, I'm going to start to catch up to you. So, a little triangle. Cosecant is related to sine, so that's related to the y piece. Since it's 4/3, that means this will be 4 and this will be 3. Is that cool? just to remind you guys, nobody's saying anything, but I always feel like somebody out there has no idea why the hell I did that. This is equal to an angle, that angle, which means that 4/3 equals cosecant of some angle. Cosecant is h over y. That's how I know what to put on those sides. So then this is going to be square root of 16 minus 9, square root of 7. Good old Pythagorean. All right, and now, so what's cosine of that angle? Cosine is going to be rad 7 over 4. And then I have to square it, which is nice because it kills my radical. So I get twice 7 over 16 minus 1. 14/16 minus 1 is 2/16, which is 1. Well, not 2/16, negative 2/16. Yeah, which is negative 1/8, I think. How's that sound? Okay. Let's see why this. All right. Any questions from that? Any questions from that at all? Even if it's from this step, I will hide the fact that it drives me crazy that you wait. All right. Somebody's telling me it makes sense to them. Okay. Everybody else is like, it's good for you. So again, you are gonna hate all of this shit if you don't have the basic stuff memorized. And at this point, I'm just talking about like what the hell cosecant is as a ratio, right? The next level is these guys, but right now, if you don't have these memorized, you can at least have that sheet sitting next to you so you can look them up, so you can start to get used to them. But you have to have a foundation or else you're not going to be able to do any of these. If you don't have a foundation of what these things mean, each one's going to be complete Greek to you. No pun intended, because they do have Greek letters. Sorry. Now I was going to ask you, how do we know this seems correct? So watch this. Well, all right. I don't want to spend too much time with this. The cosine being negative must mean that this angle, let's see if anybody, I don't know, this is pushing it a little bit. Let's see if anybody can get this. How does this angle relate to 45 degrees? Is it smaller or bigger than 45 degrees? I love this question, and all of you hate it probably. I know the answer to this question is negative. What does that mean about the whole angle in here? I know a couple quadrants it's got to be in, right? Can it be in quadrant 1? No, it's probably in quadrant 2. Okay. So it's going to be, so this piece is bigger than 45 degrees, so that twice this is bigger than 90. All right. Did that have anything to do with the answer? No, because I got the answer a couple minutes ago. It's just Jeff doing weird shit again, and I'm sorry. Okay. How's that, everybody? Is that all right? Any other specific general questions? Anything? And I will entertain any level of question. Just ask. Okay. Can you do another one? Okay. All right. Yeah. Why are you not moving anywhere? Oh, because I did this shit again. Wait, how much did I do that with? Everything. That was smart, Jeff. Hopefully you guys got that. I'm recording. I'm really sorry. But I just realized I'm not even using this draw function. I was using my zoom draw function, which can't stay there. God damn it. All right. I'm really sorry. It's recorded. You can go to that part of the video if you want to. And if you have a problem with that, it's too bad. I can't do shit. Let me think. So now I got to come up with another problem. Let's see what's a little bit different. Oh yeah, let's do this. What do you got, Jeff? There's not that many options, dude. Yeah, sure, we'll do that. Well, let's do this. Yeah, let's make it a little bit more interesting. That's a 5 up there, 5 pi over 12. The fact that this is over 12 should tell you it's related to some kind of double angle formula, right? And of course, we just talked about what this format is related to. What is 1 minus twice sine squared of an angle equal to?
Cosine 2 theta.
Cosine 2 theta. I love it. So I can rewrite this whole thing. I made that too easy, didn't I? I don't care. It's not exactly the same, is it? I didn't put any inverse shit in there. Do you want me to put some inverse shit in there? No, I don't, because then it wouldn't really work. So then cosine of twice this would be 5 pi over 6, and then you can just do that like normal, right? You're in quadrant 2, pi over 6 reference angle. So you know this is going to be negative, right? So negative cosine of pi over 6. Are you guys all comfortable with doing this kind of thing here? At this point, you really do need to be comfortable with that. No matter what I give you, find the reference angle, figure out what sine it is, and then just use the reference angle because you have that memorized. That's the whole purpose. Porpoise. That's what I was going to say.
I'm just
so negative
confused.
cosine.
Sorry.
Yes, go ahead.
About how you got from 5 pi over 12 to 5 pi over 6.
Oh, what's the angle here? 5 pi over 12, right?
Yes.
And what's the identity say happens to this angle?
Oh, it's double. Got it.
So that's a good point. I did this earlier. So again, when I rewrite this form, I've identified what theta is. So then whatever the other side of the form, I throw theta back in, and the first thing it does is doubles it. So yeah, I like it. Okay. And of course, what's cosine of pi over 6?
Negative 1/2.
No. Pi over 6 is closer to the x-axis, so cosine's going to like that. Is that all right? And again, how do you check that? Well, you just throw this in the old calculator, right? See what decimal you get, and then throw the in the old calculator, see what decimal you get. Make sure you're in radians if you check this one, because the angle was in radians. Cool. Now, we did do one like this. What, Jeff? Sine of, do you remember this? We did one just like this. Inverse tangent of 2/5 minus inverse cosine of 7/11 or something. Who cares, right? We did do one like this. And again, what's the form I'm going to write over here for myself? This is sine of theta. Well, let's see. Sure, theta plus gamma. Let's get really freaky. If you don't want to do that, you can just say sine of a plus b. It's just, that's the form, right? Angle. I'm sorry. Why am I putting a plus sign there? Minus. Jeff, learn from yourself, my friend. And what's the identity for sine of a minus b? Sine of one angle minus another angle. Sine, of course, is the nice guy, right? He says, I'll go. And then you can take a turn with me, cosine. And there's a minus. I'll keep it a minus. And then we'll both take a turn with the other one. Oh, here we go. There you go. I like it. Kick ass. And I don't know, is everybody cool with this? Obviously, this is multiplication, so it doesn't matter what order you write these in. I always just like to keep the sign first, just to make up for the poor little dude being such a pushover. And cosine's just an asshole. So now I just rewrite this, but this is A and this is B, right? So it'll be sine of this. I'm kind of losing interest in this problem because now this should be easy, I'm hoping. I'm sorry, Jeff, if I would just write the right thing, it would be easy. Maybe don't talk while you're writing. That's your job. Well, that's a problem. Cosine. Oh, this is nice. I made this really nice. So I'm just following exactly what I've written for myself here, right? I've identified who's what, and I'm just going to put them in the right place in the identity. And of course, I left myself no room here, but sine of B cosine of A. Now, each one of these, right? Each one of these is its own little problem with you draw the triangle, you find the last side, you answer the question, right? But how many triangles do I need? I just need how many triangles do I need? How many angles do I have? There we go. Somebody's motioning to me. I have two. I just need two triangles, right? So the triangle for the inverse tangent piece will look like this. And the triangle for the inverse cosine piece will look like, oh shit, I'm getting a little low here, sorry. Will look like this. Jeff, what are you doing, dude? All right. See, I give myself shit about that. I don't mind making a mistake if you immediately catch it. I almost don't want to do this, but I mean, is everybody with me? What's happening? Are you guys with me? Anybody not with me? This is the time to speak up. Not like 5 weeks from now. Okay. So 4 plus 25 is 29. And then this will be 121 minus 49 is, I don't know. What is that? 72? Is that right? What did I say? 121 minus 49.
Yeah, that's 72.
72. Yay, Jeff. Which is something 6 rad 2. There it is, Jeff. Good job. All right, there's a lot of moving parts here, correct? There are. Each moving part is not difficult. This memorization, you must memorize it. All right, if you have a really hard time memorizing, that's going to be difficult. I'm sorry, but you got to come up with a way to memorize that. I've got 4 little problems that are now easy since I've set up the triangles for them, right? So sine of this triangle is just 2 over rad 29. Oh my God, pen. Times cosine, well, this one is easy. Well, anyway, what's the cosine of this triangle? Freaking 7 over 11, because I already knew the cosine was 7 over 11. Minus the sine will be 6 rad 2 over, where'd he go, 11? You could do it, Jeff. And then times the cosine of this one is going to be 5 over rad 29. Why didn't I just didn't want to. That's why. And I don't even care about the rest. I mean, is everybody cool with that? The rest of it is just do that and then rationalize and you're done and everything's great. Okay. Yeah. No. Maybe. I mean, the big hard parts are what identity do I use? This is not necessarily a difficult one because it's just screaming at you sine of the difference. You got to remember what that is. Then you got to identify which one's which and you rewrite what the identity says it is. Yeah. Is that all right? Okay, maybe. All right. So a lot of this is decisions on your end about how to memorize these things. And I've tried to give you a few tips on possibilities, but I don't want to tell you exactly how to do it because it's up to you. This is where you start making math your own thing. Right? And I've let you in. Does anybody else teach cosine as an asshole? Well, some of my colleagues do now because I told them about it. But none of my teachers taught that shit. That's not a standard thing. That's me making it my own. I made it my own. I told my teacher, I think, and he didn't like it. He's like, how could cosine be an asshole, Jeff? It's not. All right, whatever. Get out. He was like, anyway. All right. So I'm going to stop sharing for a minute so I can collect my thoughts here. Let me see. All right. Let me know if you have anything else. We're about to get back into where we left off. Here we go. All right. I was hoping, I don't think we're going to make it there. We're going to eventually talk about the law of sines and the law of cosines. It's the first two things we do in chapter 10. Those intriguing things that are on the top of that green sheet that we have yet to talk about. So we did a couple of these equations before. Let's see. All right, let's remember how this shit works. So let's look at this guy. I like this guy. So this is barely an equation, right? This is more of a, do you have this memorized question to start with? So can somebody tell me, first off, can somebody tell me what quadrants are in for this to be true? And when I ask you that question, what is it you're looking at? I don't care what the angle is. I just want to know what the quadrants are. And what quadrant it is built off of what the sign is, right? SIGN. Where's tangent positive?
1 and 3.
4.
Yes, 1 and 3. I like it. Sine is the tangent's positive, where sine and cosine are the same SIGN. Okay, I like it. So can somebody give me the answer that's in the quadrant 1? And how do you think about this? How do you think about this? Tangent is got square root of 3 over 3. It's got 1, it's got 0, it's got approaches infinity. Those are the main options for the angles we know, right? And the way I've got it memorized in my head is tangent is the biggest, well, it's bigger when sine is bigger. So when is tangent equal to rad 3? It's when sine is equal to rad 3 over 2. And when is that true?
Pi over 3.
Yes, cool. I like it. And what's the answer in quadrant 3? It's going to be some reference angle for that. That's in quadrant 3.
Is it
So
5
if you
pi
go-
over 3?
Well, if you go, so here's the way to think about it. So if you start at pi and you go pi over 3 past that, so what's a pi plus a third of a pi?
4 pi over 3.
4 pi over 3, I like it. I like it. 5 pi over 3 would be a third of a pi away from 2 pi's. Yeah, okay, I like it.
Now I want pi.
I know, that keeps happening to me too. Now, tangents, what's tangents period?
Pi.
Pi, I like it. So and the reason that this is going to work is because one answer is in quadrant 1, one answer is quadrant 3. So I only have to rotate by 1 pi. So I don't even need to write this down. I can just capture them like this. And remember, the book's going to write that. Okay. How's everybody out there doing? So something like this starts off as an algebraic problem, right? Sometimes the algebra is going to be factoring. Sometimes it's just going to be really, really, really simple solving equation, right? So here, the first thing I would do is distribute. I'm trying to get my tangent by itself, right? So it starts off as a pure algebra problem, Subtract my tangent, subtract 6. Dang, there I am. And when does tangent equal -1? What's the first quadrant that happens in when tangent's negative? So tangent's negative when sine and cosine are different signs. It's going to be in 2 and 4. So again, we're not surprised that the angles I get are exactly 1/8 apart from each other because the period of tangent's pi. That makes sense. So if you find the answer here, you're basically done. Now here's the interesting part. This just wants all the answers between 0 and 2 pi, right? So then I might as well find the answer here too. So I don't have to write it like this. I don't have to find all infinite answers. I just have to find the ones in 0 to 2 pi. So what's the one in the second quadrant? Of course, what angle makes that happen?
3 pi over 4.
Yeah, it's going to have a reference angle of pi over 4. So it's going to be back pi over 4 from a whole pi. So it's going to be 3 pi over 4. And then this guy is going to be pi over 4 away from 2 pi's. So 2 pi minus pi over 4 is 8 pi over 4 minus pi over 4 is 7 pi over 4. All right, I like it. I'm really sorry. So many guys, your only memory of pre-calculus is going to be me saying pi. I'm sorry. I didn't want that to be your memory. Okay. So some of the problems are going to ask you specifically, find only the answers between this and this. And then some of them don't say that. So you better give me some kind of plus pi k or 2 pi k or something, right? All right. So let me clear all this.
Can you explain how you got to that equation in blue again, please?
Down here, this one here.
Yeah, how you went from the equation they gave to that other equation. You just
So pretend like tangent x is a variable. I'm trying to get tangent x by itself, right? Is that all right? So like, how would you solve this equation up here?
Oh, okay, makes sense. Got it.
Yeah, so this function can be a square root function, it could be squared, it could be a trig function, whatever, wherever my x is, my first step is to try to get that thing by itself, and then I can attack it head on. So that never changes in any part of algebra, even trigonometry. All right. Let me clear all that away. Go away. Now this is just use a calc. Who cares? Use a calculator. Who cares? Real quick on this problem here, it says use a calculator to solve this, and it has a secant. So what the hell would you do?
1 over cosine.
I like it. And you can now watch this. So secant theta is -4. So 1 over cosine theta is -4. So what do you do to both sides to get cosine? Is that all right? Do you guys see that? So I could have actually just went straight there. Secant, I flipped that and I flipped that. Whatever I do to one side, I've got to the other side. The flip of secant is cosine, and the flip of -4 is -1/4. Now what I'm going to shove into my calculator. How do you kill this?
Inverse cosine.
Yes, you apply the inverse cosine. And then you just throw this in the old calculator. Make sure that you're in radians. Does everybody Nobody's asked me this, but is everybody cool with how to change your calculator from radians to degrees and vice versa? I'm pretty sure I showed you that a while back. Let me know if that's something you're not sure how to do. Because remember that whole story I gave you about the whole quiz that I got completely wrong? Yeah, you're like, yes, Jeff. You had to walk uphill both ways when you took that quiz. We know. All right.
Does
And
the
it was,
inverse,
go ahead.
sorry, does
Sorry.
the inverse cosine change the 1/4 into a
Oh, shit.
positive, or did you
No,
just
no, I
put
just
it?
left
Okay.
it out. Yeah.
Okay, just checking. Thank you.
Thank you. Thank you. And obviously that's not something we have memorized. So that's why I have to use a calculator for it. I like it. So this problem is much easier. It's already in terms of an inverse that I have on my calculator. So I don't have to change it. But that's how you do any, woo! That was neat. You just flip both sides. So you make it into a non-reciprocal trig function. Okay, so let me clear all that. Blah, 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 blah. And we did some like this. Pretty sure we did. This one's rough. Ooh, this one's rough. I like this one. Why would they put that here? Let me see. Is it? Yeah, I think I told you. All right, I want to make sure that they did this on purpose. I did tell you guys that you could use quadratic formula for these. I personally don't like giving that too much. So, if you see in the homework, do it. But I mean, what would I do? Here's what I would do. So I can make this in the form of something I'm used to. I would rewrite this as x squared plus 3x minus 1. Then I would do quadratic formula. Get out of the play. Let's do whatever. Negative b plus minus square root of b squared minus 4ac all over twice a, blah, blah, blah. So I get x equals negative 3. Is this right? I did that kind of quickly. Who knows? Yeah, I think it's right. Okay. Right? And then what's x? X was cosine theta. So then how do you do this? Well, I'm going to put inverse cosine of negative 3 plus rad 13 over 2. And then I'm going to put inverse cosine of negative 3 minus rad 13 over 2 into my calculator. Is that cool? So the first step, again, very often the first step is purely algebra. And to make it even more so, you can replace the repeated trig function with x. Because what is cosine theta? I don't know. Let me call it x then. That's what algebra says I could do. Any damn time I don't know something, I can call it x. Just make sure you don't stop here, because my question is about theta. You better bring back the theta. Yeah. You guys with me? That's a very useful tool to use. Later, it's going to be called U substitution, because we'll use like a U here instead of an X, but it's just making it easier to look at, really. So pretty cool with that. You guys all right?
Yeah, so this would actually have two answers then?
Looks like it. Yeah, it could have more than these two, because you got to make sure that you're going to pick up all the ones that are in there. So what you're going to get here is going to be a reference angle. Where will your, so you'll have a reference angle between 0 and pi for this guy, and you have a reference angle between 0 and pi for this guy, right? So you could have another answer down here. So let me clear this. Let's take a look and see what they got. Pop. All right, there's that business. There's the inverse cosine thing, 1.265.02. Let me see. Did they do anything interesting? I don't know what they did here.
They just said it like where it's like 2 pi minus the inverse of cosine on the bottom. I don't know what that's about.
What do you mean? Oh, here.
Yeah, I don't.
Let's see what they did here. I'm very curious. Oh, this is what I was talking about. All right, so this is a reference angle. All right. This is a reference angle. I don't know why they ignored. Oh. This one actually ends up having no answer because that ends up being, I mean, -3/2 is already less than -1. So when you subtract negative rad 13, it gets even more less than -1. So that actually doesn't give us an answer. And we've seen that kind of thing happen before. And that's fine. 1.26. Somebody help me out. This is 0. This is pi/2, which is roughly 1.57. This is pi, which is 3.14. So 1.26 is in the first quadrant, right? And all right, there's a lot going on here. -3 plus rad 13 is positive. Is that cool? Because rad 13 is bigger than 3. So it makes sense that this is going to be in the first quadrant, right? So the other answer is going to be here with this as a reference angle. So this is 2 pi. How do I get to this angle? I subtract that. So that's why they're doing this. They just didn't really explain it very well. Yeah. Okay. How often is this going to happen? Not. How often will it happen on the quiz I give you? Never. I'm not really interested in the quadratic formula shit on top of the trig stuff, right? But this is nice. You can only see it still happens. It's still doable. Okay, what time we got? Man. All right, I want to do one thing that will get us ready for chapter 10 real quick. Let me bring back my, can I do it here? I don't care. Let me see, where's my, oh yeah, that's right. Why is nothing working? There you are. Let me do this. Hey, look, it's me. And just give myself some more blank. Okay, so this is the last thing we're doing tonight. Obviously, it's almost closing time. Let's see, how do I want to draw this? Sure, all right.
We can
Wanna
still see
prove-
9.5, by the way.
What is it?
We can still see 9.5 if you're expecting us to see something else.
I got you. Thank you. Please definitely do that for me. Let me try this again. Get out of there. All right. So let me draw this triangle. Doesn't really matter what it looks like, to be honest. It would matter that it would match up. All right. Let me call this A, angle B, angle C. I'm going to call this side little c, side little a, and side little b. All right. So I'm going to prove a real quick thing to you that's going to help us in the next chapter. I don't think this has come up yet. Let me draw the height in here because I want to find the area of this triangle using these things that I know. So I don't know the height. This is what I'm given. I'm given these angles and I'm given these sides. I'm not given the height. When I draw the height in, what kind of triangles have I just created inside this big triangle?
Right triangles.
Right triangles, because the height is defined to be perpendicular to the base. So if I can figure out what the height is, I can figure out what the area of the triangle is, because that's what it is, this being base. And actually, that's kind of nice. I didn't even do this on purpose. It doesn't matter what letters down there. Whatever the base is, we go here. All right. So can I figure out an expression for H? Ache. Does anyone see a way to figure out an expression for H in terms of all the stuff that I know? Don't I have, let me redraw. Well, crap. You can make it look somewhat like it looks like. Come on, Jeff. All right, I'm going to redraw this triangle here. So this is the triangle with A, C, and H, right? So can somebody tell me what H is in terms of A and C? This should be little c, but oh well. We like to use capital letters for, it's hard to do little c because it looks just like big C. Can somebody come up with an expression for H? Well, what trig function relates these two sides with this angle?
Sine.
Sine. So sine of A would be the y piece over the hypotenuse. I like it. But what about this other triangle? Doesn't it also have H? And it's the one with angle C, and it's the one with A. So what's sine of C over here?
H over A.
All right, I like it. So what's H equal? H equals C sine A, but H also equals A sine C. Some weird shit. So right there, so we just proved, let me show you what we've proven. The area of any triangle, watch this, is 1/2. Let me see if you guys are cool with this. The base times, in this case, it would be C sine A, or I can have 1/2 the base times A sine C. Now stay with me. This is kind of like a side discovery. Does it make sense when I say that C is the angle between side A and side B? Do you see what I mean when I say that? C is the angle contained between side A and side B. C is the angle contained between side B and side A, right? A is the angle contained between side B and side C. Holy shit. Right? So I could turn this triangle around. If you don't settle down, kids, I'll turn it around. And I could make the area, go away, stop it. I can make the area 1/2 AC. If I use A and C, what's the angle between them? B. This works for any triangle, any triangle. The area will be 1/2, one side times the other side times the sine of the angle between them. That is such a beautiful discovery. And from this, we will discover, oh, shit and a half. God damn it, sorry. Or we will determine the law of sines next time. But I wanted to get this out here because it's on its own, it's important, but it's also where law of sines comes from. Coolness. All right, that's enough. That's enough. So let me know if you need to hang out. Otherwise, you may go and get your weekend started
Thank you.
anytime. All right, I'm assuming everybody's good. I'm out of
I
here.
had a question.
Oh, yes.
I wasn't here yesterday, so I wasn't able to ask about my test. Actually, I had a couple questions. Number 2, the 5 tan 6 pi x minus the pi over 3.
All right, hold on. I got you coming here. Let me look your quiz up. All right. Here you are. Okay. I might as well stop recording.